Today we have to learn about carbon and its compounds. Today we have to learn carbon and its compounds. Especially carbon and its compound means we have to concentrate on carbon. Why we have to concentrate on carbon? Because you take food items, clothes, medicines, books and many things surrounded you are made with a carbon. That's why it is called versatile element. It is called versatile element. Okay. And you see, the body is made up of. Our body is made up of carbon compounds. Example, protein, fats and nucleic acids. These are all made up of with carbon. That's why it is called as a versatile element. So we have to study more about a carbon. See, now we will go through the carbon. Number one, its physical properties we will see. Physical properties, and due to its versatile nature and its bonding in carbon. So these are all the important points why we have to read on carbon, because due to its physical properties and versatile nature and also bonding in carbon. These are all the very important points. We have to concentrate on these. And what about chemical properties? See, chemical properties means chemical properties of the both diamond and graphite are same. So we are getting a allotropes of carbon. Allotropes of carbon are main. One is diamond and the second one is graphite and third one is fullerenes. So these, if you are talking about chemical properties, the chemical properties is same for all. The chemical properties of both diamond and graphite are same. So that means we need not worry about chemical properties. We have to worry about physical properties. And physical properties, if you see this, it is occurrence of carbon. Occurrence of carbon and Earth's crust. Crust having 0.02% carbonates carbonates, hydrocarbons, coal and petroleum. Okay, so earth crust is having 0.02% of carbonates. Carbonates means CO3. CO along with a metal. Okay, and hydrocarbons, coal and petroleum. And 0.03% of carbon dioxide in atmosphere. In atmosphere. Okay. And this carbon exists in both crystalline and amorphous forms. So that's why you got a allotropic forms of carbon. Okay, now due to this you will get allotropic forms of carbon. So in this you will get one is diamond, and the second one is graphite, and third one is fullerenes. Okay, now we will see the structure of diamond and graphite and what are the physical properties that we will see. Fullerenes, it is not discussed in our textbook. Only diamond and graphite is very, very important, that we will see now. See this is the diamond structure. So it is a natural hardest substance. It is natural hardest substance. So this they will ask in the examination. So diamond is it is natural. This is important. Natural hardest substance. And diamond is bad conductor of electricity. It is a bad conductor of electricity. This is also important. They may ask in the examination. And it is three-dimensional. So what is three-dimensional? One is y-axis, and second one is x-axis, and one more axis. This is z-axis. All three dimensions you can see. Just you concentrate here. See each carbon atom. This is the center of carbon atom. This carbon is bonded with this carbon atom and neighboring this carbon atom and this carbon atom and this carbon. This makes the diamond three-dimensional. Okay. So now valency of carbon is satisfied. That is also important. Okay. And the explanation is each carbon atom is bonded to other carbon atoms. I told you na. See, this is the center of carbon and it is connected with 4 neighboring carbon atoms. That is the meaning. And bonds, you see, all bonds are single. All bonds are single. See, this is also important. This is also important. They may ask in the examination. And why it is a bad conductor of electricity? So that we will see. Because the bonding in carbon hydrogen doesn't give rise to any ions. That's why it is a bad conductor of electricity. Now we will see the graphite structure. Okay, it is a soft and slippery. See, this is the hardest substance and this is soft and slippery. Soft and slippery. See, it is a good conductor of electricity. See, this is also important. They may ask in the examination. Graphite is a good conductor of electricity. Diamond is a bad conductor of electricity. See, you have to see whether they have given diamond or graphite. That you have to see. Then only you have to answer the question. Okay. And this is 3-dimensional. What about here? This is a plane giving hexagonal array. Plane giving hexagonal array. Just you see here, you concentrate on this carbon. See, this carbon is a center. It is connected to neighboring carbon and here neighboring carbon and here one neighboring carbon with a double bond. Okay, so this is very, very important. So due to this double bond, it is a good conductor of electricity. Okay. And each carbon atom is bonded to 3 other carbon atoms. Just you see here, this is the center. This side on carbon and this side on carbon and this side on carbon. Okay. So each carbon atom is bonded to is bonded to 3 other carbon atoms. So it is hexagonal array, that means one above the other. Just you see here, this is one layer, and this is one layer, and this is one layer, and this is one layer. That means it is arranged one above the other. Okay, hexagonal array one above the other. Okay, this is the meaning. And next, one double bond and remaining all single bond. Remaining are single bond. Okay, these are all the important points on graphite. So in this you will get a questions on its electrical conductivity, and you may get the hexagonal structure. So these are all the important points. And fluorescence they have not discussed, but it is having C60 which has carbon atoms arranged in the shape of a football. So they may ask this one is, it is carbon 60 which has a carbon atoms arranged in the shape of football. This may ask in the examination. Keep it in mind. Okay. Now this versatile nature we will see. Why it is having versatile nature? Because due to its unique nature of carbon. Due to its unique nature of carbon. What is the unique nature of carbon? Because it is having small size. Number one. And number two, strong covalent bonds between carbon and hydrogen. Covalent bonds between carbon and hydrogen. Then how we will decide this the strong covalent bonds or unique nature? What is the unique nature of carbon? That we will see. So what is the unique nature of carbon? It is having number one, catenation. And number two, it is having a tetravalency of carbon. So what is the unique nature of carbon? It is it is catenation, and second one is tetravalency of carbon. Now catenation, that we will see. See, catenation means carbon has a unique ability to form bonds with other atoms of carbon, giving rise to large number of carbon-carbon compounds called catenation, and gives long branched and rings. So what is the catenation? That we will see, that we will write in next. One is catenation, second one is tetravalency of carbon. Now what is catenation? That we will see. Carbon has unique ability to form bonds with other atoms of carbon, giving rise to large molecules. See, one carbon atom, it will form a covalent bond with carbon, again it will form covalent bond with carbon, again it forms covalent bond with carbon. This is continuation. This is called catenation. See, carbon itself forms a bonds with carbon atoms. That is called catenation. So due to this, what is happening? It is giving long, branched and rings. See, I will give long chain means, see, just you take butane, 1, 2, 3, 4. So this is the long hydrocarbon. Suppose it is branched. Branched means 2 carbon and carbon. This is branched. 4 carbons only, but it is branched. This is long, this is branched. Rings means just like benzene ring. This is ring. So this is long hydrocarbon, branched hydrocarbon and ring hydrocarbons. Okay. And one more thing, just you see here, this is single bond and here also single bond. What about here? The double bond you can observe here. Okay. That is why carbon atoms may be linked by single, double or triple bonds. Okay. So now you have to categorize. Suppose all bonds are single, then what they are going to, how they are going to categorize. So that means single bonds are called saturated hydrocarbons. And a double bond and a triple bond. Bonds between their carbon atoms. Their carbon atoms are called unsaturated hydrocarbons. Hydrocarbons. And this carbon-carbon bonds or bond is very strong, and stable. This gives large number of compounds. So here what they will ask, this unique ability or unique nature of carbon they will ask. That is, one is due to catenation and second one is tetravalence. That is very, very important. They may ask in the examination. Now we will discuss on bonding in carbon. No, tetravalency, that we will see. Tetravalency first we will discuss. This tetravalency of carbon is, carbon as a valency, just carbon structure, it is its atomic number of carbon is 6. Now what is the electronic configuration of it? Now we are having K, L, M, N shells. So for our study, these 3 shells are important. So the K shell is always, it is filled with, full filled with 2 electrons. L is also 8 electrons and M is also 8 electrons. Here you see carbon is having atomic number 6. That means its electronic configuration is 2, 6, 2, 4. See, this is half filled. Due to this half filled electrons, it is giving a tetravalency. That is very, very important. Okay. So now we will write the definitions. Carbon has valency of 4. That means 4, how we got, we have seen in the previous. Okay. Now it can share it can share 4 electrons. 4 electrons to with other atoms of carbon. Other atoms of carbon as well as oxygen, hydrogen, nitrogen and halogens. Okay, so these are all the important points on tetravalence. Now bonding in carbon we will see. Bonding in carbon. Carbon, this carbon shares its 4 outermost electrons with self or oxygen or hydrogen or nitrogen or halogens, etc., etc., and forms noble gas configuration. What is noble gas configuration? See, we are having K, L, M, N, and here it is 2 and here it is 4. That means carbon, either it can lose 4 electrons or it can gain 4 electrons. Losing is very difficult. Why? Because protons in the nucleus are same. Because protons we are not losing. So that's why losing is very difficult. That means it is gaining 4 electrons either from halogens or from hydrogen or from oxygen. Okay. So that means it is, suppose if carbon gets 4 electrons from hydrogen, what will happen? It will become 2, 8. So this is 2, 8 is there, no? This is noble gas configuration. That is the meaning. Okay. Your doubt? I clear? Okay. Now we will see the example. We will see example methane. So formula is CH4 and its structure is carbon is center and hydrogen sides. Okay. So this methane is there, no? You may get questions on this. This methane used as a fuel. It is used as a fuel. And this is a simplest organic compound. All are important. Okay. And it is a major component of biogas. It is a major component of biogas. This is also important. They will ask in the examination. Or it is also a major component of compressed natural gas. So it is a major component in compressed natural gas. Compressed natural gas means CNG. This is also important. They may ask in the examination. Okay. Suppose all valencies of the atoms are satisfied by single bond. Such compounds are called saturated compounds. Suppose all valencies of all the atoms are satisfied by single bonds. Such compounds are called saturated compounds. Okay. So for this example, it is methane. Methane. That means structure you see. This is the structure. Suppose double bond forms between carbon and neighboring atoms are called unsaturated compounds. Okay. And one more thing, unsaturated compounds are more reactive than saturated compounds. This is important. They may ask in the examination. Unsaturated compounds are more reactive than saturated compounds. So these are all called hydrocarbons. Hydrocarbons. This is very, very important. Okay.